Two-dimensional questions get a little bit larger in their solution, like a little bit more math. But if you understand the concepts of the one-dimensional explosion, it's the same thing. We're just going to do it twice, once in the east-west component and then again in the north-south component. I'm always going to push for a drawing. Here, let me talk you through what I'm thinking when I made this one up. So I don't know what this 1 kilogram toy would be. If I ever see something like this for sale in a store, I'm going to buy it. But let's say we got this thing. It weighs 1 kilogram. It's kind of spring-loaded, and for fun, to give like these kids a surprise, just it kind of randomly pops apart into 3 pieces. One of the pieces, the numbers I made up, it's got a mass of 500 grams, flies off and it goes straight north at 3. Another piece, the numbers I made up, weighs 300 grams. It goes straight west at 4. There's a third piece, it's got to weigh 200 grams to add up back to our 1 kilogram. I don't know which way it goes, but I know momentum's conserved. Initially, we'll do all the math on it, but initially the 1 kilogram wasn't moving, so it had no momentum. Nothing east-west, nothing north-south. Finally, we've got a piece that's flying straight north, so I know the 200 has to have some southward momentum to cancel out the northward momentum of the 500. Similarly, I know the 200 has to have some eastward momentum to cancel out the westward momentum of the 300. So I'm literally going to make a guess. This 200 one is going to go down this way somewhere. And for notation, I'm going to call this V with a little c. I'm going to call that block C. That's what I don't know. We're going to apply conservation of momentum in components. It doesn't matter what order we go. I'm going to start with the east-west component. In the east-west, momentum is conserved. If we wanted to do...
Judy Boyer, please call 1520. Judy Boyer, please call 1520.
Our classic sort of starting point for explosions is all the masses summed together, going at the initial speed, and then after the fact, just split them up into their parts. I'm going to put the prime on to indicate after. I'm putting all these letters down, but a bunch of them are zeros, so I didn't really need to write them down, but just to sort of give you a flavor for how it looks, I'm going to write them all down. In the initial case, so on the left-hand side of the equal sign, the masses all add up to 1 kilogram, but they weren't moving. So this whole thing on the left of the zero, of the equal sign, since it's got a speed of 0 initially, this whole term drops to 0. After the fact, let's say that the 500 gram, let's call that A, the 300 gram I'm calling B, and then that means the 200 gram is C. Right after the collision, the 500 gram isn't moving east or west. It's moving straight north. So it doesn't contribute anything to the east-west momentum. So for MA times VA prime, that contributes a 0. Oops, let's clean up my colors. That's a 0. The B block, it is moving east-west. So since its full velocity is pointing straight west, its full speed is going to count as the momentum. It was a mass of 0.3, moving at 4. Notice I didn't really worry about signs yet. Conservation of momentum will take care of it for me. Notation-wise, I'm going to have a second VC later, so just to clean this up, I'm going to put a little east at the bottom because I know that this block is going to be flying somewhere to the east. Doing the math on that, VC east with the prime for after. Doing the math on that, I'm going to get a negative number. And doing a quick math in my head, I'm getting 6. Really what that means is this block is moving 6 meters per second, the opposite direction to the 4, so 6 meters per second east. We'll need that later after we consider the north-south component. So it's kind of like what we did in one-dimensional, just focused on the east-west, did the same sort of physics. Now we're going to repeat it. We're going to focus on the north-south. North-south component and do the same basic conservation momentum. Initial equals final. It started off with one big object made up of 3 parts times the initial speed. That's split into 3, so I'm going to write it all out. My notation isn't great. Maybe I should be putting like something to indicate north-south with all of these. But as long as we're organized and keep track of it all. Similarly to what we did before, I'm going to put a little n by this VC so I don't get them confused. Initially, nothing was moving, so we get a 0 on the left of the equal sign. Initially, the one that I called A, that's the 500, it was moving 3 meters per second straight north. So that is a contribution in the north-south, so 0.3 multiplied by, 0.5 multiplied by 3 is the momentum of the 500 gram block. The one that we called B was moving straight west, so it didn't contribute anything to the north-south. And the one that we called C, it's got some speed in the north-south component. We'll do the math to figure out what. Flip-flopping things around, we're going to get a negative number again. I'm getting VC in the north component is 7.5 with a negative. So that means it's going 7.5 meters per second south. Now we're done the momentum part of the question. We figured out that if this thing explodes into 3 pieces, that third unknown piece must be going 6 to the east and 7.5 to the south. This is a question we could have handled in grade 11. We're just going to put those 2 vectors together. Oops. 6 to the east would look like this. 7.5 south would look like that. We're adding those 2 vectors, so connect the very, very start to the very, very end. Doesn't matter what the vectors are. It could be that they walk 6 kilometers east and then 7.5 kilometers south. Always adding vectors, drawing one. Where it ends, draw the second. In this case, it's nice because it turns into a Pythagorean theorem thing. So VC prime all squared is 6 squared plus 7.5, sorry, getting a little bit messy, squared. You can do the math on that. I got, after the square root, that it was 9.6. To get the angle, we're going to use tan function. The tangent angle SOHCAHTOA, 7.5 over 6. Crunching that out, I get, 51 degrees. Putting it all together, now we're done. The velocity of the third piece had a value of 9.6. Its units are meters per second. And the direction was from straight east, we rotated 51 degrees towards the south. So east, 51 degrees south. Really what we did is we applied that explosion concept twice. Once in the north-south, once in the east-west, and then put the components together to get the final answer.